refresher on this. What's 4 minus 7? -3. And so what's the absolute value of -3? 3, because distance always has to be positive. Good.
So the answer was 3.
Answer was 3. Okay, straight edge. Straight edge. What's a straight edge? Anybody know? Can we give an example of a straight edge? A ruler. Anything else? Something that you have on your desk right now. A pencil, paper, folder, notebook, book. All right, those are straight edges. Anything with a straight edge. Edge has a straight line. Compass. Compass is a tool that is used to make circles. There's one in your little box here. I can pull one up. It's got a little sharp piece. That's where your center of your circle will be. So you make a little point, put that little piece there, rotate your pencil around to make a circle or an arc. Be very careful. They have to be lined up just right. So if you have a question, make sure that you ask for help. You can use a straight edge and a compass to make constructions. So in other words, you can make triangles or rectangles or pretty much any normal shape using a straight edge and a compass, and it'll look perfect. Okay? It's really kind of neat how to do it. There's instructions in your book. Also, we know that line segments can be measured because it has 2 endpoints. Can anybody tell me why we cannot measure lines? Good. They go on forever. Same with rays. All right, but line segments are a piece of a ray or a piece of a line that you can actually measure, find the length of. All right, so that's what we're going to be doing today is finding lengths of different things. When using your ruler, make sure you notice the markings between the whole numbers. If you look at the ruler in your box, from 0 to 1 on the inches, it's got 16 little bitty markings. You see those? It means that each marking between the 0 and the 1 is a 16th, 1/16, 2/16, which you can reduce down to 1/8, right? 3/16, 4/16, and so on. So if you're using that, make sure you don't just round it. It would be incorrect. Make sure you follow those, whether you're dealing with inches or centimeters. All right, coordinates on a real number line. Our coordinates is the real number that corresponds with a point on the line. So if I'm dealing with a number line, the point that's plotted out for you is an actual number, whether it's a whole number or one with decimals and fractions, and an integer. Remember we talked about distance and length? They have to be positive. That's why we use the absolute values here. Okay, distance and length has to be positive. If I have 2 numbers on a number line, I just subtract them from each other and make sure that my answer is positive. Got it? 2 numbers on a number line. Say this was -4 and this was 3. I just made that up. Well, 4 minus 3, that's -7. But distance has to be positive, so we take the absolute value of it and make it 7. Is that okay? Any questions? Anytime you're given a number line, you can take those 2 points, subtract them from each other, and make sure that the answer is positive, and you get the length or the distance between those 2 points. A math term only is betweenness. Okay, betweenness is in terms of distance, and an example is if R is between P and Q. You draw me a line segment with the point P and Q on the end, and R is somewhere between it. All right, if you read that, that's how you would draw it. R, P, and Q are all collinear. That means they're on the same line. And then you can use this postulate. It's called the segment addition postulate. You'll be using that a lot. You want to circle it or highlight it or something so you know, but you can find it. All right, in other words, if I break my big old long line segment up into smaller parts, like PR, the length of PR plus the length of RQ gives me the whole length. Are you with me? The length of PR, whatever that distance is, plus the length of RQ gives me the whole length of PQ. Okay with that? Now look below. PR plus RQ equals PQ. These are talking about the lengths of the segments. Does anybody know why this doesn't have a line above it? Why does PR not have a line above it to tell me it's a line segment? What did I say it represented? You may remember? Didn't I say it represented the length, the measurement? Okay. If you're talking about the length or the measurement, okay, we're no longer talking about naming the line segment. Got me? If I have PR side by side, I know that I'm talking about the length. If I see PR written with a little line segment above it, I know you're actually just naming that segment. You got me? You're going to have that on your test. You're going to have to know the difference. So, two smaller sections of the segment added together give me the bigger segment. With me? PR plus RQ gives me the whole segment. I'm not sure if you're with me. All right, here's an example. Points K, L, and J are collinear. What's collinear mean? Same line, thank you. So I have points on the same line. It says if KL is 31, JL is 16, and JK is 47, determine which point is between the other two. What are my two endpoints? Anybody over here? Okay, endpoints are just a point. So what are my two endpoints? Okay, JK and JL, that's 3 points you just gave me. You gave me J twice and L and K. Just the J and the K. Those are my endpoints. Now, how did you know they were my endpoints? Because, look, 47 is bigger than 16 and 31, isn't it? So you know that those have to be on the end. And what has to be in the center? Or somewhere, not necessarily center. It has to be L. The point L has to be somewhere between them. Because JL is 16, KL is 31, and this whole thing is going to equal 47. All right, so what is the point in between the other two? The point. Good answer. Anybody else? What is the point between the other 2 points? L. How do you name L? How do you name a point L? How? Just what? Not a cursive L, but a capital L. Thank you. Guarantee you that's going to be on your test. Example 2, you have FG equals 12, FJ equals 47, find GJ. Okay, my hint is G is between F and J. So your endpoints are what? There you go. F and J, and G's in between them, somewhere. I don't know if it's halfway in between. It didn't tell me, so I'm just putting it in somewhere so I can have a visual of what's going on. FG is 12. The whole segment FJ is 47. How do I find GJ?
47 minus 12.
Oh, very good, because he knew that 12 plus some number equals 47, so he just said 47 minus 12 gives me that answer. What's 7 minus 2? 5, and yeah, and then 4 minus 1 is 3. So GJ, the length of GJ is 35 units, whatever units. Does that make sense? That's the segment addition posite right here. All right? He just solved for the Missing piece. Don't forget when you're doing your homework, and that's going to be very crucial later on, measurements have two parts. The first one is to find the answer, the measurement, the length of the value. And then the second part is the unit of measure. And we get in a hurry, and we forget to put it on our answer. And guess what? It's wrong. You're right. And I will count off points, and it will add up tremendously if you leave it off. So check yourself. Take your time. Make sure you don't leave it off. If you're unsure, ask. Okay, but if you're taking a test, make sure, put units. If you're unsure and you don't see anything, put the word units. Okay, you're at least going to get some points. It's better than leaving it blank if you're talking about length. Length measurement has to have two parts. The actual number that you get and the unit of measure. Okay, congruent segments. The only way I've ever seen it in the book, the symbol for congruent is an equal sign with a little squiggly. Now, I just got a poster that has one little straight line and a little curved line in it. I don't know. I guess it may be new, but this is the way that I've learned it, and this is the way that I've only seen it. So why don't you use that one to be safe? Two segments with the same length. Okay, it means they're congruent. Same exact thing. All right? So that means that if I find a length of one thing, let's say right here, got this example. Well, DE is a length of 1, 2, 3, 4. Okay? So DE is congruent with what other thing? What else has a length of 4? EF. Okay? And these are the segments, and segments are congruent. Lengths are equal. Got me? The lengths are equal. They're the same measurement. But the segments are congruent. So I've got to have that segment line above it. Did I confuse you? Remember, this represents a segment. That's why there's a line there. Segments are congruent. If you're talking about lengths, they're equal. All right, you got me. You're with me. Segments are congruent. Lengths are equal. All right, there's more. We could have done S to H, E to G. They're the same length. They're congruent. Also, GH is a length of 4 too, right? Yes, magic. All right, coordinate plane. Here is a formula you need to know, period. You will have to learn it. So I'm going to highlight it for you. You will have to learn it. Okay, the square root. That's what this little nice long thing is, this whole thing. But you do the square root the very, very last thing of your whole entire paper. Got it? The square root, parentheses, x2 minus x1, close it, square it. So you'll do the inside the parentheses first, then exponents, right? Over here, inside the parentheses first, then exponents. Then once you get those two answers, you add them together. This should be always positive. If it's not, you did something wrong. This should always be positive. If not, you did something wrong. The answer. When you square it, okay? Once you square this part right here, it should always be positive. This should always be positive once you did this step. Okay? When you add them together, they should still be positive because they're both positive. Take the square root of that positive answer. If you get a square root of a negative answer, it's going to shoot out an error in your calculator, and you did something wrong. All right. Use the distance formula when you're given a coordinate plane. Now remember, coordinate planes are points on your x and y axis, right? You remember that? Everybody remember that? And then your first point is always x. The first number in your coordinate or your ordered pair is x. The second one's always y. All right? We have two of them when we're finding the distance, right? You've got two x's, you've got two y's. You got another x over here and another y. All right, so you've got your square root of your numbers. We have two coordinates, x and y, x and y. These little numbers below it, you see this example right here? It's got numbers, x1, y1, x2, y2. Those are called subscripts, and they mean nothing other than this is a group together, these numbers are grouped together. The 2's are grouped together, the 1's are grouped together. So like this would be x1, y1, x2, y2. And it doesn't matter which ones you call the 1's or the 2's, you're going to get the same answer. As long as you group these together in the x1 spot and y1 spot, and this in the x2, y1, or y2 spot. So let's add a page. So I'll give you an example. If I had a coordinate plane, I had a point here, and I'm going to call it 2, 3. And I have a point over here, -1, 2. Okay, and I want to find the distance between those 2 points. I'm going to use the distance formula. x2 minus x1, close it, square it, plus y2 minus y1, close it, and square it. All right, so remember, does it matter which one I call the x1 or y1? No. I just call the first ones I come to the 1s. And I call the second ones I come to the 2s. All right? And then I just substitute it into the equation. Square root, keep it there, because if you lose it during your work, you forget to put it in your answer. All right, first thing, x2. Well, in my case, it's 2, but it doesn't really matter. Then I have minus a -1. You see that double parentheses? Why did I put a parentheses around that -1? Anybody? Good, because you know that there's a subtraction of negative. All right, and we'll deal with that in a second. Squared plus y2, which is 3 minus 2 quantity squared. All right, somebody help me out. Do their algebra. What happens when you have a minus a negative?
Plus a positive.
Good, it becomes a positive. So you've got 2 plus 1 squared plus, what's 3 minus 2? 1 squared. Now keep it in parentheses, because if you keep it in parentheses, your calculator will give you the right answer. If you don't, you could get the wrong answer. Because remember, when you square it, you're always going to get a positive number, right? What's 2 plus 1? 3, and 3 squared is? 3 times 3 is? 9. And that's what a lot of people do. They'll say 6. Or if you get 2, 2 squared is 4. But if you do 4 squared, it's not 8. It's what? 16. Be very careful. Just check yourself. 1 squared is 1. What's 9 plus 1? Square root of 10. Now, you may have to simplify that later, but right now I'm happy with it. Okay? I'm happy with that as being your answer. The square root of 10. Now, if you're in my CP class, then you have to simplify your radical. But in CTP, you do not. Is that okay? Anybody have questions? Pythagorean theorem, right triangles only. Okay, you can only use Pythagorean theorem if you have a right triangle. Everybody know what a right triangle looks like? Okay, kind of here below. Usually has a little bracket right here. This A and B are your legs. It does not matter which one you call the A and which one you call the B. But it has to be the side touching the 90-degree angle. Your legs will touch the 90-degree angle. Do you see that? This is a leg. It touches the 90-degree angle. This is another leg, and it touches the 90-degree angle. The hypotenuse is always directly across from the 90-degree angle. It does not touch it. All right? So if I had a right triangle, and I had two sides of that right triangle, and I want to find the hypotenuse, okay, I can use Pythagorean theorem. The leg squared So a squared plus b squared equals the hypotenuse squared. 2 squared is? 4 squared is? What's 4 plus 16? 20. Do you remember how to get rid of a square from algebra? Take the square root. To get rid of a square, you take the square root of both sides. Now, when you do that, you really get the both positive and negative of that square root. Right? The square and the square root cancel each other out, so done. So you just get the c. But when we're talking about distance, do I have a negative distance? Do I have a negative length on this right triangle? No. So really, we're only worried about the square root of 20. Again, you have to have the square root thing because it's different from 20. The square root of 20 is going to be 4 point something. Okay? And if you write 20, that's a completely different number. Everybody okay with that? No questions? All right. One example on the distance formula. All right. We have 120 degrees longitude. Now, longitude, is that vertical or is it horizontal? Up and down or side to side? Very good. So would that represent my x or my y values? Y. Y'all got it. Kind of tricky how it was worded, right? Could mess you up if you had it on your ACT. And then NASA is at 37 degrees latitude and 122 degrees longitude. Okay? So all you have to do is the distance formula. Not too bad. I'm not going to use the formula or rewrite it. I'm going to take my x values. I'm going to call this the 1s. And I'm going to call these the 2s. Make sure your little subscript's at the bottom of the variable and not the top, because that means something completely different. Okay, it means you're squaring it instead of being just a piece of recognizing information. So x of 2, 37 minus 39, square that whole quantity, plus, if I got it from 37, then I have to get 122. It doesn't matter which one's first, as long as if you choose 37 to be first on the x's, then 122 has to be first on the y's. All right, so if you choose 39 to be first, then 120 has to be first on the y's. Is that all right? They've got to line up with each other. First here in your group. So 122 minus 120 squared. 37 minus 39 is what? Negative 2. And then you get 2 over here, squared. What happens when you square a negative number? Anybody know? What's negative 2 times negative 2? Somebody on this side is what? Positive 4. All right, it is a positive 4. Negative times a negative makes a positive. That's why I said parentheses is important, because if you don't have them, you may write down what the calculator says, and that would be wrong. All right, so that's positive 4 plus another positive 4, which is a positive 8. Square root of 8. If you wanted to know the actual number, you take that second x squared button in your calculator, type in 8, hit enter. Gives you the decimal form. I'm not going to make you guys simplify it or reduce the radical, but my CP class will. All right, let's find the missing link. What would you use? Would you use distance formula or Pythagorean theorem? Pythagorean theorem, because it's a right triangle. It's not a coordinates, is it? If it's not your x and y coordinates, you got to use Pythagorean theorem. A squared plus b squared equals c squared. Okay, what's my c value? Somebody on this side. No, none of y'all talking. 25. All right. Does it matter if 10's my A or my B? No, thank you. I don't care if you called it your A. Still gives you the same answer. What's 10 squared?
10 squared,
100. A lot of people do 10 times 2. Be careful. It's not. It's 10 times 10. Which is 100. 25 squared is 625. Subtract 100 from both sides. How do you get rid of a square? Take the square root. Remember, we are only interested in the positive square root. That's why I'm only writing positive square root of 525. Check yourself. Check the calculator. Make sure it doesn't come out to be a whole number. This one doesn't. Okay? But square root of 25 would be what number? 25. And the square root of 100 would be 10. So check yourself and make sure that the square root doesn't come out to be a whole number.
a whole number.
Like if I take the square root without a decimal, if I take the square root of 25, I'm going to get 5. But if I take the square root of 26, I'm going to get 5 point something. Okay? So if it comes out to be a number without a decimal, give me that final answer. If it doesn't, you'll leave square root of 26 as your final answer. Okay.